Researchers of social choice theory have come up with a list of mathematical criteria that can be used to evaluate electoral systems. In this video, we'll review 8 of these criteria and view them through the lens of 3 electoral systems: plurality voting, approval voting, and ranked choice voting. Let's define the 8 criteria we'll be looking at. The first that we'll discuss is called the majority criterion. When we discuss voting systems, we frequently identify which systems result in a majority-supported winner. This criterion is a little different than that, however. This criterion is not determining whether or not an electoral system always results in a majority-supported winner. But rather, this criterion is making the statement that if any candidate does win the majority of the votes, then that candidate should win the election. It should not be possible for a candidate to win the majority of the votes and still lose the election. The next criterion is called Condorcet Winner. The Condorcet Winner is the candidate that would win in a head-to-head election against each other candidate in the election. This criterion states that if there is a candidate that would win in a head-to-head election against every other candidate, then that candidate should win. Similarly, the Condorcet Loser criterion states that if there is a candidate that would lose against all other candidates in a head-to-head, then an electoral system should not allow that candidate to win. Next is the consistency and participation criteria, which are 2 separate but related concepts. Consistency states that if a candidate is winning, adding more ballots for that candidate should not cause that candidate to lose. Participation states that voting sincerely should always be better or equal to not voting at all. This means that voting for one's favorite candidate should not cause that candidate to lose. Later no harm and later no help are also separate but related concepts. Later no harm states that adding a lower ranked candidate to one's ballot should not harm higher ranked candidates on one's ballot. And later no help states that adding a lower ranked candidate to one's ballot should not help higher ranked candidates on one's ballot. So combined, adding a lower ranked candidate to one's ballot should have no effect on the higher ranked candidates already included on that ballot. Monotonicity states that it should not be possible to harm a candidate by increasing that candidate's rank on one's ballot, and it should not be possible to help a candidate by decreasing that candidate's rank on one's ballot. Independence of clone alternatives states that the existence of a non-winning similar candidate should not change the outcome of an election. Violations to the independence of clone alternatives include the spoiler effect, which is when the existence of a similar candidate can hurt a candidate, and the reverse teams effect, which is when the existence of similar candidates helps a candidate. And lastly, we have the independence of irrelevant alternatives. This states that the addition of any non-winning candidate should not affect the result of an election. In other words, the only way an additional candidate should be able to change who wins an election is if that new candidate wins. Now we'll take a look at 3 electoral systems to see which systems meet which criteria. Keep in mind that a yes means the electoral system meets the criteria 100% of the time. A no means that it is possible for the electoral system to violate the criteria. It does not mean that the electoral system violates the criteria in every election. We also don't want to simply count up the yeses and nos to determine which electoral system is best. This chart isn't all-encompassing of every possible mathematical criteria. It only includes the 8 that seemed most practical and applicable. And using mathematical criteria on its own to evaluate an electoral system is insufficient, since there are lots of other factors to consider, such as voter education, election costs, and many other non-mathematical criteria. Further, within this chart, we'll need to evaluate each violation in terms of frequency of violations, severity of a violation, and whether or not a violation can be taken advantage of strategically. So, with those caveats in mind, let's take a look at this chart. We'll dig into a few of these. Let's start with the first row, majority criterion. We know that in plurality, if any candidate does achieve over 50% of the vote, then that candidate is the winner of the election. The same is true of ranked choice voting. But in approval voting, this is not true 100% of the time. So approval voting is listed as failing this criterion. Now we need to think about how frequently this criterion is violated in approval voting. What is the severity of the violation, and can the violation be taken advantage of strategically? Well, the reason approval voting violates this criterion is because in approval voting, more than one candidate can win votes on over 50% of the ballots, since voters can vote for more than one candidate. The result is still that the candidate with the largest majority wins the election. So while this could happen frequently, the violation might not be considered severe, since the winning candidate is still the candidate with the largest amount of support. Can it be used strategically? Well, in order to win, a candidate still needs to get the most votes. So not really. Let's take a look at the monotonicity violation for ranked choice voting. This indicates that it's possible in a ranked choice election for a voter to harm a candidate by increasing their rank on their ballot. This is due to the fact that changing the rank of candidates can change which candidate is eliminated in which round and affects which candidates square off in which rounds. The frequency of this occurring is thought by researchers to be about 5 to 15% of the time. It would be difficult to take strategic advantage of this criterion failure due to the very specific numbers of votes that would need to be changed and the fact that those numbers would be undetermined until all ballots were in. Now let's take a look at the independence of clone alternatives violations, plurality voting. Since we are all familiar with plurality voting, this one is a little easier for us to recognize. The spoiler effect is a concrete example of a violation of the independence of clone alternatives. It occurs frequently in plurality elections, and the result of its occurrence is often that the least preferred candidate wins an election. This violation is one that lends itself to strategic advantage, as groups have been known to strategically nominate candidates in order to pull support away from similar candidates. Taking a look at one example for each electoral system, in order to show how one takes into consideration the frequency of violations, the severity of a violation, and whether or not it can be taken advantage of strategically. Versions of this chart will be included in our written study. At the end of each section that evaluates an electoral system, you'll see a copy of this chart focused on that specific electoral system, with notes for each potential violation that discusses the frequency, severity, and potential for strategic advantage. We hope you find this information helpful in your evaluations.